combustion, calorific value, and questions related to heat of combustion. Students, in last class, I have given one question. Question is, I have given heat of combustions or heat of formation, students? Last question. Given values are, yes, given values are heat of combustions. What is heat of formation? Okay, one more question, students, and try this question. The heat of combustions of carbon, hydrogen, and CH4 are minus 94, comma, minus 68.3 and minus 212.8 respectively. Kilocalories respectively. Kilocalorie per mole respectively. Calculate heat of formation of CH4. Tilak, wrong answer. Kartikeya, the screen is clear. Okay, how can we solve this question? Ropak, very good. So we need to calculate heat of formation of CH4. First of all, we have to write equation for heat of formation of CH4. Carbon how many? 1, 2H2 gives rise to CH4. heat of formation for 1 mole. Okay, right. So from the given values, how can we get this equation? Heat of combustion of carbon. Write the equation. Carbon plus oxygen gives rise to carbon dioxide, right? For only 1 mole. 1 mole of carbon. Hydrogen, H2 plus of O2 gives rise to H2O. Delta H for this reaction minus 94 kilocalorie per mole. Delta H for this combustion minus 68.3. And CH for combustion, CH4 plus 2O2 gives rise to CO2 plus H2O. Okay, 2H2O. Delta H for this one is minus 212.8. So the how can we get this equation? By taking all these equations. Students, if you observe, CH4 actually in the right side, but in the equation here, left side. We must reverse this equation. If you reverse this equation, this will be right side, this CO2 H2 will be in the left side. Okay, convert this equation. CO2 plus 2H2O. Now here 2O2 plus CH4. If you reverse the equation, this delta H will be positive. If it is already positive, it will be negative. Okay, and in equation we have two hydrogens, but here only one hydrogen. Multiply with 2, 2H2, 2, 2H2O, again 2. And now add all this. Carbon dioxide here, left side here, right side, cancel. Water 2H2O, 2H2O cancel. Here 2O2, O2 plus O2, 2O2 cancel. Finally reaction C plus 2H2 gives rise to CH4. We constructed this equation by using three equations. Simply add all these again. Delta H equal to minus 94 minus 2 into 68.3 plus 212.8. And this value is minus 17.8 kilocalories. Students understood? Students, board is clear? Right. Thank you. Abhinash, please check your internet. Students, no need to write all these equations all the time. I said one simple trick. The trick is, question is heat of formation is given values are heat of combustion. Simply sigma heat of combustions of reactants minus sigma heat of combustions of products. If you use this formula, you will get directly answer. Okay, understood? Okay, one more question. The heat of formation of carbon dioxide, H2O, and ethyl alcohol are minus 94.3, comma, minus 68.5, and minus 64.1 kilocalorie per mole, respectively. Calculate heat of combustion of C2H5OH. So now given question is calculate heat of combustion and values given values heat of formations. Now try this question, students. Srivardhan, wrong answer, Nana. Yuvate is wrong answer. Okay. Students, first of all, we have to write heat of combustion of ethyl alcohol equation. C2H5OH plus oxygen gives rise to carbon dioxide plus H2O. Any organic compound under combustion, definitely carbon dioxide and water would form. Balance this equation: 2 carbons here, 2 CO2, hydrogen total 6 hydrogens, 3 H2O, and oxygens already 4 plus 3 7, here already 1, 3 O2. Yes, balanced. Heat of combustion of ethyl alcohol means it must be 1 mole. It must be 1 mole. Okay, right. With help of given values, how can we get this equation? Heat of formation of CO2, heat of formation of CO2 equation, carbon plus oxygen gives rise to CO2. Delta H for this minus 94.3. Heat of formation of water, H2 plus of O2 gives rise to H2O. Delta H for this one minus 68.5. Heat of formation of ethyl alcohol. How many ethyl alcohol formula C2H5OH? How many carbons are needed? 2. 2C. How many hydrogens are there? 3. 3H2. How many oxygens are there? Only one oxygen of O2. Delta H for this minus 64.1. So with help of these values, how can we get above equation? If you observe C2H5OH in the left side, but in the right side, just reverse this equation. I just keep minus here. Minus, 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 minus into minus plus. And carbon dioxide right side, but how many carbon dioxide? 2 carbon dioxide. So multiply with 2, 2, 2, 2, multiply with 2. How many hydrogens? So 3H2O. So 3H2, 3 by 2O2, 3H2O. Student, just add all these equations now. Okay. 2C here plus C, here 2C is minus C. 2C, 2C cancel. 3H2 is plus minus 3H2 cancel. And remaining minus means here C2H5OH. 2O2, 3 by 2 O2 minus of O2, it is 3O2. Gives rise to 2CO2 plus 3H2O. We got this equation. And add all these values. Delta H of heat of formation, heat of combustion of ethyl alcohol now minus 2 into 94.3 in plus 3 into minus 68.5 plus 64.1. That is the answer. Students understood? Remaining students understood? Okay, I'll give again, students. Listen. Question is heat of combustion of ethyl alcohol. You need to write heat of combustion, students, first of all. After that, with help of heat of formations, how can we get that equation? Heat of formation means from the elements. So carbon plus O2, CO2. H2O, H2 plus of O2, H2O. Ethyl alcohol, C2H5OH. How many carbons? 2 carbons, 2C plus how many hydrogens? 3, 3H2 and of O2. And by adding all these equations, we should get this value. If I reverse this equation, because C2H5OH in the right side, left side in the equation, but in the equation right side, just reverse this equation. If you reverse this equation, this will be negative, 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 positive. I need 2 carbon dioxide, but here only 1 carbon dioxide. Multiply with 2 into 2. I need 3H2O, but here only 1 H2O. 3H2, 3 by 2 O2, 3H2O into 3. Now add all these equations. Everything will cancel except these values. And add all these values. Are you getting? No reply from other students. Are you getting or not? Tell me. Okay, right. And I'll give very simple trick, students. The trick is, and shortcut for this, if given values are heat of formations, and question asking is heat of combustions, then formula is sigma heat of formations of products minus sigma heat of formations of reactants. So write the equation. First of all, in these equations, products are 2CO2, 3H2O. So 2 into heat of formation plus 3 into heat of formation of H2O minus oxygen heat of combustion they won't give, because, and heat of formation of C2H5OH, you will get heat of combustion of C2H5OH, because heat of formation of elements generally we have to consider as zero. So for elements they won't give heat of formation. Right, students, I'll give one more example for this. Completed. Okay, right. So question is, heat of formations of CH4, CO2 and H2O are minus 74.8, comma, minus 393.5 and minus 286.2 kilojoules per mole. Calculate heat of combustion of CH4. Srivardhan, very good. Ropak, very good. Ramya, wrong answer. Okay. Heat of combustion of CH4. First of all, write equation for combustion. CH4 plus 2O2 gives rise to CO2 plus 2H2O. Balanced? Yes. Now, heat of combustion of CH4 formula sigma heat of formation of rocks minus sigma heat of formations of reactants. So one of the product is carbon dioxide. Carbon dioxide, no, one of the product is what? H2O and carbon dioxide. So carbon dioxide is minus 393.5, one carbon dioxide. And water's 2, so minus of 2 into plus 2 into minus 286.2. Why 2? Because here 2 moles of H2O. It is for 1 mole. Minus of reactant only CH4, carbon oxygen, heat of formation 0. So CH4 minus 74.8, only 1. So minus of minus plus. If you add all these, you will get minus 891.1 kilojoules per mole. Students, understood? Do you want one more question? Okay, right. Heat of formations of CCl4, H2O, carbon dioxide, and HCl are minus 28.9, minus 28.2, and 28 point students, 28.5, sorry, comma, minus 57.8, minus 94.1, and minus 24.1 kilocalories per mole respectively. Calculate heat of combustion of CCl4. No, student, wait. Calculate heat of combustion of following reaction. Calculate heat of combustion of the following reaction. CCl4 plus 2H2O gives rise to carbon dioxide plus 4HCl. Okay, students, next concept is heat of neutralization. So what is heat of neutralization? At a particular temperature, the amount of heat energy is evolved when 1 gram equivalent 1 gram equivalent of 1 gram equivalent of an acid is reacted with 1 gram equivalent of a base completely is called heat of neutralization. HCl and NaOH react together, we will get NaCl plus water. Yes, this process is called neutralization reaction. HCl must be 1 gram equivalent. NaOH must be 1 gram equivalent. When 1 gram equivalent, 1 gram equivalent react together, delta H is always minus 13.7 kilocalorie per mole. Simply not mole, kilocalorie, 1 gram equivalent. Students, for any strong acid, strong base, 1 gram equivalent, 1 gram react together, delta H of neutralization minus 13.7 kilocalories or minus 57.3 kilojoules. This value is fixed, students. Whether it is H2SO4, HNO3 or any other acid, it must be 1 gram equivalent. NaOH, KOH, MgOH twice, any base, but it should be 1 gram equivalent. Then the liberated value always minus 13.7 or kilocalories, minus 57.3 kilojoules. Completed, students. Okay. So please remember, it is very important point, students. Please note down this. Okay. Gram equivalent number, gram equivalents we can find by weight of the given compound by molecular weight by n factor. Simply weight by gram equivalent weight. This value must be 1. If it is 1, minus 13.7 kilocalories. Okay. So one question, students. If 4.9 grams of H2SO4 reacted with 4 grams of NaOH, calculate heat of neutralization. Okay, students, what is the answer? First of all, we need to find how many gram equivalents of H2SO4 is given. Gram equivalents of H2SO4, weight 4.9 by molecular weight 98, n factor 2. So it is 0.1. Similarly, gram equivalents of NaOH 4 by 40, again it is 0.1. For 1 gram equivalent of H2SO4 and NaOH react together, the released energy minus 13.7 kilocalories. If it is 0.1, answer minus 1.37 kilocalories. Students understood? Say yes or no? Okay, right. So very easy, students. Very easy. Given amounts converted into gram equivalent number, first of all. Then we know that for 1 gram equivalent number, amount of energy released minus 13.7. For 0.1, how much? Okay, right. Okay, students, all the best for tomorrow Monday's exam. Thank you.